Hello all, we are starting lesson 3, volume of pyramids and cones. Okay, the reference sheet. This is given to you when you take the Regents. It's at the back of the Regents. It was also given to you in class. It is also on the website. So if you don't have one, get one. I actually copied off all the formulas that we need for this lesson so that it saves us time. And if you think I'm going too fast, just pause the video and take the notes and then move on. Okay, because otherwise it'll take forever. So let's start with our do now. The do now is asking us to use the reference sheet to state the volume formulas for the following solids. A general prism. Volume of a general prism is big B times H. I would not call it base, and I want you to keep that in mind. What does big B means? Let's write that down. Pause the video and you can copy the notes and then listen to what I'm saying, or you can first listen and then copy. So big B is not the base. It is area of the base. Okay, so whatever your prism is, if I say a rectangular prism, you're going to substitute with the area of a rectangle. If I say square prism, square, you will do that, and so on. Okay, a pyramid. You've all seen pyramids, and what is the volume? Right off your reference sheet is 1/3 big B times H. Again, big B is the area of the base, right? Or we can also rewrite it as big B times H/3. Multiplying by a 1/3 or multiplying by a third is same thing as dividing by 3. And then let's go to cylinder. Remember, the base of a cylinder is a circle. Cylinder is basically, if I stack up a lot of circles, I get a cylinder, right, of the same radius. So it is pi r square h, where r is the radius and h is the height. Cone is very similar to the cylinder, but it is exactly the formula of the cylinder, but a third of it. So 1/3 pi r square h, or again, I can multiplying by a third is same thing as dividing by 3. So now let's go on to this. It says, explain how the volume formula of a cone is related to the volume formula of a cylinder. So let's copy this. A cone is, I tried to draw some pictures here of a cone and a cylinder. If you have the same height and the same radius, right, that's something what a cone looks like, and that's a cylinder. All your cans are mostly cylinders, right? So so what is the relationship? I can actually, 3 of these can fill up one of those. So that's why I said a cone is 1/3 the volume of a cylinder. 3 cones equals 1 cylinder. Same thing with the pyramid. Explain how the volume formula of a pyramid is related to the volume formula of a prism, which we looked up here also, right? The formulas were same, but what was the only difference? That 3 pyramids can fit into 1 prism if they have the same height and the same base. Okay, so 3 pyramids equals 1 prism. Let's get started with our example 1. I'm going to read the question and then we're going to try understand what the question is saying. A cone fits inside a cylinder so that their bases are the same and their altitudes are the same. So the bases are same. Look over here in the picture. The bases are same and their height is the same, right? Which looks like that. So now it says calculate the volume that is inside the cylinder but outside the cone. Give an exact answer in terms of pi. So first of all, what does exact answer means? Whenever it gives you that, if you have a calculator, you should have it with you. If you don't, then just try, I'll do the calculations for you. Do not put pi in the calculator. So when you're putting in the whole formula, right, you do not put the pi in the calculator. You're going to leave the pi out. So what is it saying? Let's understand the question. It wants us to find the area of this region, which is outside the inside the cylinder but outside the cone. So I'm going to put that cone in there, and then basically how many more cones do I need? 2 cones. So either you can find the volume of 1 cone and multiply it by 2, or the easiest one would be if I take the volume of this whole cylinder and subtract this volume of this cone, am I not left with this outside area, right? And that's what we're going to do. We're going to write, I already wrote the formula. volume of a cylinder minus the volume of a cone will give me the area of the remaining region. So the volume of a cylinder is what? Pi r square h. So what is my radius? My radius is 5 and my height is 12, right? Now remember, what did we say? We're not going to put the pi in the calculator. So put that in the calculator, which is, so you're going to just put these numbers in the calculator. So it's going to be 300 pi. Now 1 over 3 pi r square h, which is again the same numbers because we said we have the same radius, right? So the same bases and the same height, and over 12, which would be what? If we simplify this, we get 100 pi, right? And what are we doing with these two volumes? We're subtracting them. So the volume of the remaining region is 300 pi minus 100 pi is what? 200 pi. So that's our answer. So the volume of this remaining region is 200 pi. Okay, so let's get started with our next question, which is on page 2. Let's turn the page. So I have the formulas. I want to just hide it so that we first read the question and understand it and then take it from there. It says find the volume of the following rectangular based pyramid. If you can draw a picture, good. If the picture is given to you, that's even better, and which in this case it is given to us. It is this pyramid, right? So I copied the formula. The formula of the pyramid is 1 over 3 big B times H. I want you to copy that. The B is the area of the base. Okay, so what is this rectangular base? So what am I going to replace my big B with? A rectangular area, right? So what's the area of a rectangle? Let's type width. So I substituted my big B with length times width. So that was only the hard part that you had to understand in this question, because rest all the dimensions are given to you. All you need to do is substitute in. So length is 9.5, width is 8, and my height is 9. Put that in the calculator and I get an answer of, let me just quickly check. My answer is 228 centimeters cubed. So volume of this is 228 centimeters cubed, right? That's what this is. So this was a straight substitute and check. I hope you can try this question on your own. Pause the video and try this on your own before I get started with this. Okay, so I'm going to read the question. It says a square based. So the minute I read that it's a square based, I'm going to say the area of a square is what? Side square. So I know I'm going to substitute my big B with side S square. It has a volume of 245 inches cubed. The height of the pyramid is 15 inches. Since determine the length of one side of the base. So we copy the formula, right? And we're going to substitute big B with S square. We already talked about that because it's a square base, right? Now this is a little different because here we're not finding the volume. The volume is already given to me. So all I'm going to do is, once you have the formula, you're going to just substitute these things. You have 3 things, right? The 3 variables here, and you know 2 of them. You want to find the third one. So you know your volume is 245, 1/3. You don't know your side square, but you do know your h. What's your h? Your height is 15, right? Simplify this side. It's basically 15 s square over 3, right? What is 15 divided by 3? 5s square, right? Now solve for s. Divide by 5, and I get s square equals 49. What's my last step? How do I undo a square? You take the square root. So s is equal to 7. So the length of this, or one side of this pyramid, is what? 7, right? So that's what it was. We really didn't need the picture for it. It was more of understanding what would I substitute my big B with. Okay, so now let's read this question. It says, determine the volume of the cone shown below. Give an exact answer in terms of pi. Again, we have another one of those exact answer questions. So what do we know? Do not put pi in the calculator. Right? In the calc. So I'm just going to abbreviate that. So I copied the formula from my sheet, right? And now look here. I know my height. I need my, it says r squared times h, right? So I know my r. I don't know my r. I don't know my radius. I just know my height. But here I don't know the diagonal length, right? What kind of triangle is this? It's a right triangle, right? I'm going to highlight it. So look here. This is a right triangle. I know two sides of a right triangle. And I want to find a third one. What do? I guess you guessed it right. The Pythagorean theorem. Very good. Which is a squared plus b squared equals c squared. So my c here is the key thing. Always whenever you're using the Pythagorean theorem, you need to know what your c is. Your c is the hypotenuse across from 90 degrees, which is 100 square root of 137. Right? Let's call r just r. So this would be r squared plus b squared, which is 11 square. Solve it. The square and the square root cancel out, right? R squared equals, subtract 121 on both sides, you get equals 16. So r would be what? Take the square root is 4. A radius is 4. So that was pretty simple, right? We've all done this for quite some time. Now, once you know your radius, all you're doing is substituting in 1 over 3 pi. What's my radius? We just found it. 4 square h. Even if you didn't know to use the Pythagorean theorem, you should have, when you were substituting in, you should have encountered that, oh my god, I don't know my radius. How do I find it? Look at the picture. Luckily, the picture was given to you, right? And the height was what? 11. And if you substitute all that in, put that in the calculator. Again, when I'm doing this, I'm not going to put the pi in the calculator. So what do I get? I get my volume is equal to, I think it's 176 over 3 pi. I did not put that in the calculator. Okay? So now we have 2 more questions. And let's get started. It says, if a cone and a cylinder have the same volume and the same altitude. Same volume. Key words. Same volume. Means the right? And the same altitude. Altitude is what? Height. Same h. And the cone has a radius of 9 millimeters. Find the radius of the cylinder in the simplest radical form. It's not saying the radius is same. You cannot write that, oh, the radius is same and done. No. So we know the 2 volumes are what? The volume of a cone is what? 1 over 3 pi r square h. We said the 2 volumes are the same. So I can, when they mean same means what? We can set them equal to each other. Right? Now let's substitute in. Do I know my radius of the cone? Yes, I do. It is 9. So 1 over 3 pi 9 square. And h, the height is same. So I'm going to keep it as h. Again, pi. I am looking for this r. And I'm going to keep that h because it said they both have the same height. It didn't give us a number, but they said they have the same height. So we keep the same variable. Right? So now let's solve it. What happens is when you have the same variables on either side, it's all multiplication. So these will cancel out. Right? The pi's cancel out, the h's cancel out, and what are you left with? 9 square is 81. 81 divided by 3 is 27 equals r square. Okay. If you did take the square root of 27, you do get a decimal. Right? That's how you simplify. So we don't want decimals. We want them to be in simplest radical form. So you need to look for a perfect square, largest perfect square that goes into 27. I'm going to take it here on the side and do it. So what is the largest perfect square that goes into 27? It's 9 and 3, right? So we're going to do square root of 9, square root of 3. What is square root of 9? Is 3. So 3 rad 3. So your radius is what? 3 rad 3. If you did not simplify it, you would lose a point because it did ask you to leave it in simplest radical form, not in decimal. So decimals would not be an acceptable answer. Again, pause the video, see if you can do this question. Not very tricky, but a little bit of thinking involved. Okay, so let's read this question. Example 6. Walter wants to make 100 candles in the shape of a cone for his new candle business. The mold shown below will be used to make the candles. Each mold will have a height of 8. So the height of 8 I've already marked on this, and it's inches, and the diameter is 3 inches. This is the diameter. Diameter is the length across. If you weren't aware, this is a circle. That's the center. Diameter is this, right? This is the diameter, which is 3 inches. But I don't want the diameter because my volume formula for the cones uses radius. So which would be, what's half of 3? 1.5. So that's why I wrote 1.5 there. Okay, so that was one of the things that you had to keep in mind. So your radius is, let's write that down, 1.5. You know the volume of a cone is what? 1/3 pi r square h. So what is this? 1/3. I want to find the volume of 100 candles. If I find the volume of 1 and multiply it by 100, wouldn't that be it? So h is 8. Put that in the calculator and you get, and this time you are putting in the pi into the calculator, right? Don't round it, nothing. Multiply this by what? 100, because we're working with 100 candles. And what do you get? It is 1884.9, right? And it's said to the nearest cubic inch. So it's going to be approximately how much? 1885 inches cube. And that's it. So finish the last sheet for homework. Try those questions. It's a must that you practice those. And have a great day. Bye-bye.